Hi Year 12, today what we're looking at is indefinite integrals. So to find the indefinite integral of fx dx, we find the antiderivative of the function. This is where the integral of x to the power of n dx equals 1 over n plus 1 x to the power of n plus 1 plus c. This is where n cannot equal minus 1. So let's find each indefinite integral. So for the integral of 3x squared minus 2x plus 4 dx, what we're doing is we're just finding the antiderivative. So we'll have our 1 over our n of 2 plus 1 times our 3x to the power of 2 plus 1 minus 1 over 1 plus 1 times 2x to the power of 1 plus 1 plus 1 over 0 plus 1, 4 times 4x to the power of 0 plus 1 plus c. Now do not forget that plus c. What this equals is a third times 3x to the power of 3 minus a half times 2x to the power of 2 plus 1 times 4x to the power of 1 plus c, which equals a third times 3 is just 1, so x cubed, minus a half times 2 is just 1, x squared, plus 1 times 4 is just 4x, to the power of 1 is just x, and then plus our c. Now, you only really need this line. If you can get straight to this line without making any mistakes, then that is fine. Our next example that we're going to look at is finding the indefinite integral of 2 over x cubed. So what we want to do here is, give me 2 seconds to move this question up. What we want to do is change the how we have a fraction to have a negative indice. So what this will equal is the integral of 2x to the power of negative 3 dx. So this is equal to 1 over negative 3 plus 1, because that's what our n is, times 2x to the power of negative 3 plus 1. And we have to have our plus c on the end. Like I said before, our plus c is the most important thing to not forget. So we'll have this equals 1 over negative 2 times 2x to the power of negative 2 plus c. And so then we have 1 over negative 2 times 2 is equal to negative 1 times x to the power of negative 2 plus c. We can write our negative 1 times x to the power of negative 2 as negative 1 over x squared plus our c. Now, do not forget your plus c there. Our next example, we have the integral of x root x dx. So we want to get rid of this square root and we want to write it with indices. So this is x times, now instead of writing root x, it is x to the power of a half, and we can write our first x to have a power of 1 with respect to x. So what this equals is using our index law. So using our index law, a to the power of m times a to the power of n, we need to add our powers together. So we'll have x to the power of 3 on 2 dx. We can now find the integral of this by going 1 over our n of 3 over 2 plus 1, x to the power of 3 over 2 plus 1, and do not forget to plus your c on here. So then what we have is for our 1 over, we'll have 1 over 5 over 2, x to the power of 5 over 2 plus c. And for our 1 over 5 over 2, this denominator of 2 comes on the numerator, so it equals 2 over 5. So when we have 1 over a fraction, it gives us the reciprocal of that denominated fraction. So that means we're going to have 2 on 5, x to the power of 5 on 2 plus c. And what we have with our x to the power of 5 on 2, that is using our index law, a to the power of m on n, so that's the nth root of a to the power of m. So that means we're going to have 2 squared square root of x to the power of 5 over 5 plus c. Alrighty, our last example here is to find the rate of airflow into a container is given by r equals 4 plus 3t squared millimetres cubed per second. If there is initially no air in the container, find the volume of air in it after 15 seconds. So we have the rate of airflow. So we have r is our rate of 4 plus 3t squared. Our rate is talking about the change in volume in terms of the change in time. So we can write this as dv on dt equals our 4 plus 3t squared. So we want to we want to do the antiderivative, which is the integral. So we'll have v equals the integral of 4 plus 3t squared with respect to t. What we then need to do is we need to find the integral of this. So the integral of 4 is just equal, the antiderivative of 4 is 4t, plus the integral of 3t squared is t cubed, and we need to add our c on at the bottom here. Once we add our c on, we have that v equals 4t plus t cubed plus c. In our question, we're told there is initially no air in the container. So remember, initially means when t equals 0, t equals 0, we'll have that v equals 0 because there'll be no volume in the a volume of 0 of air in our container. So we want to substitute that in, and that is going to give us our c value. So we'll have 0 equals 4 lots of 0 plus 0 cubed plus c. So therefore c equals 0, and therefore we'll have our volume equation is 4t plus t cubed plus 0. And we are being asked to find the volume of the air in it after 15 seconds. So we're going to sub in when t equals 15. So we'll have v equals 4 lots of 15 plus 15 cubed to get v equals 3,435 millimetres cube of our air after 15 seconds. What you guys are going to do is complete exercise 704, questions 1 to 3 ACE, and then questions 4 to 7.